Thank you very much, and good morning to everyone. But first, let me please thank the organizers for all the work they've done, and I certainly didn't really contribute to make their task easy, so I feel I have to apologize for this. And I'm also sorry, recently I'm experiencing some loss of vision, which is currently affecting my work a little bit, and including, of course, this presentation. So I then apologize in advance because the contents of my talk are not exactly those I had in mind at the beginning. And quite honestly, having seen what's been presented so far, I'm even a little ashamed about what I'm going to present myself now, which is 3 different cases of GIS employment in archaeological and topographical research in Laconia. The first is mapping archaeological remains within the urban environment of ancient Sparta, mainly, but not only. I dealt with Hellenistic and the Roman periods. Second, collecting and assembling the documentation of the excavation of the sanctuary of Apollo Iakintos at Amyklaion, south of Sparta. And third, mapping ancient archaeological evidence at a regional scale in Laconia. And in all these 3 works, I dealt basically with cold cases, let's say. I mean, with data created either analogically and or digitally, but not designed for a GIS. So this data had to be processed beforehand, as we will see. And by the way, I must point out that besides the Amyklaion excavation, I worked with published data only. And I'm focusing on data specifically because we cannot do any computational analysis without some solid, substantial, and profitably compiled digital data sets. And putting data sets together, as you all know, is not obvious nor always easy. And in any case, it requires a lot of effort. And it is surely time consuming. So I embarked in these 3 projects separately and in different time periods, but I'm now putting my best foot forward to bring them together as coherently as possible towards a multi-scale approach in mapping ancient Laconia. This work is still in progress, but methodology and some of the data I think are worth sharing. And I wish, of course, I was there with you to discuss vis-a-vis some of the problems I've encountered and still encountering, but I hope there will be occasions in the future to do it in person. But let us start from Sparta, because the idea of mapping the archaeological evidence of the city sprang first some years ago when I started looking at Pausanias's description of the city and attempted a rereading of this section of the Periegesis. And it was then when I first started to get in touch with the GIS, choosing it as a means to collect and organize the documentation that I was extracting from the publications. Preliminarily to archaeology, though, in order to map Sparta, I had to solve the lack of a useful cartography. What I mean by useful, okay, previous scholarship has always based its work on the plan by Vasily Sejik made for the British expedition in 1906, which is, of course, an excellent plan, but nowadays we may need something a little different. And after some research and many failed attempts as cartographical base, I choose Google satellite imagery as a base map because it's the product I found that offers the best imagery resolution, and 1 to 5,000 topographical maps of the Hellenic Military Service, the GIS, that I digitized and georeferenced in-house. And I found the result quite acceptable. And although already useful, as they are, these images picture the modern city and bear too much graphical noise. And then digitized the contour lines by hand, and including waterways, toponyms, and other topographical elements. And the final outcome was a meaningful and clean digital elevation model over a hillshade model. Then I began georeferencing old maps, including those by the British School at Athens, and I found the results sufficiently accurate for the purpose of mapping archaeology. And this is the general plan by Sejic that we've seen before. Now, georeferencing major maps and plans was essential for mapping monumental archaeological evidence, such as in the case of the buildings at the Paleokastron, the archaeological site here, but also in other areas of the city. But monumental archaeology was just a fraction of the mapping, which extended throughout the whole urban area and included rescue excavations. And the Bible for this kind of mapping, of course, is the Archaeological del Tion. And I checked roughly 150 volumes, extrapolating the single reports, and then tried to locate these excavations on the map. And I'm going to present a quick overview of some of the significant cases that exemplify the methodology I've put together, progressing by trial and mistake. The first was using Google Earth. Georeference the excavation plans according to the features visible on the sat imagery, but this was more the rule of a thumb rather than proper methodology. And I realized the hard way that a considerable number of excavations were then overbuilt by modern constructions and therefore not visible from the satellite. And then case number two. In this example, the excavation plot is easily identifiable from Google Earth despite the building. The positioning was not very accurate, but the result was still acceptable, at least at the beginning to me. Sometimes, like in this slide, Google Street View came in handy to spot the building because here we have a fabulous comoterium. Because often plots are identified by a full street address. Such a down-to-earth operational approach changed when a discovery of mine changed everything. And it's the digitized maps of the Hellenic cadastre, the ktηματολόγια. And it was naive of me, but I didn't know about this when I started. But thanks to these cadastral maps, guesswork was over because these maps allow for a safe and quick targeting of the excavation plots. And how is that? Nearly all the excavation trenches that we find drawn on plans on the reports are based on parcels' edges, and therefore I could rely on cadastral parcels to identify plots and georeference the excavation plans. And this is an example. Of course, the cadastre didn't solve all the issues because plots have changed over time, and some of the past excavation plots are indeed hard to spot, when sometimes not completely impossible. It's completely impossible to spot them sometimes. But I've left these cases for future mapping. One last mapping case I wish to present has to do with major monuments. Can you still hear me?
Yes.
Yes.
Okay, good. Thank you. Just making sure that I'm not doing a soliloquium. So in 2010, works for the modern water supply system brought to light one of the ancient gates belonging to the Hellenistic and Roman city walls. This gate is excavated and published by Dimitris Vlachakos. To my knowledge, is the only one investigated and safely identified in Sparta. And here we can see the excavation plan in red, the British School map in black, and other rescue excavations in white. This image, sorry, it's a bit confusing, but it shows that the reconstruction of the city wall ring done by the British expedition in the early 20th century is quite reliable, and recent interventions confirmed it. The area we are dealing with here is to the northeast of the city, corresponding to the ancient district of Limna. And we know this because of the sanctuary of Artemis Orthia, which multiple literary sources locate precisely at this district. And the presence of the gate northeast of the city, to my knowledge, is novel and significant information, which can inform us on the road network, not only within the city, and here we can see a good amount of excavated lanes in this district, but also beyond the urban area. And we will get back to the regional road network after having touched upon case 2, so the GIS work at the Amyklaion. This work first involved dealing with old documentation, and aerial photos are part of it. They were taken in several years with a camera attached to a balloon, and I tried to develop this series of pictures into photogrammetric orthophotos by first creating the orthomosaic and then georeferenced it in post-production according to some known control points. And the result is not too bad, I think, considering that these pictures were taken a decade ago and were not meant for photogrammetry. And among the old documentation, site toplands have been the most challenging to adaptation for GIS. And although excellently manufactured, they were drawn by hand and then polished on AutoCAD. The topographical positioning was done mainly according to the excavation grid squares, and translating it properly into the EXA 87 reprojection has been quite an unsuccessful task until last year, when a QGIS release came out equipped with a new tool capable of georeferencing not only rasters, but also vectors. And that has been a turning point, at least my way of using it, because thanks to more than 300 control points, then double-checked with GPS and total station, it revealed itself as an unexpectedly accurate tool and yielded a precise georeferencing to the centimeter of the whole plan. And having all the plans properly positioned has paved the way to further implementation of GIS, for instance, to the phasing of the structure done by assigning the chronology to each and every object on the attribute table. The phasing work is still ongoing, and this is just a preliminary proposal, but the next effort is integrating not only structures, but also deposits into the system, and to link the deposit forms with the finds catalog. And here we have a preliminary example. Because this work is still at the preliminary stage, and it will progress along with the excavation, further excavation, and then the study of the material. But one more thing worth mentioning is the georeferencing of the plans of previous excavation projects. And here we have that of Zundas, that of Fichte and Furtwängler, and that of Buchon. But the GIS is now profitably employed as an essential tool for the ongoing research at the Amyklaion project, and in particular, it is now indispensable for the investigation of new plots around the core of the hill. And in these new areas, the GIS is helping to combine a set of new data that we are currently collecting there, starting with some geophysics carried out by the University of Münster, plus the results of the remote sensing analysis carried out by the Archaeometry lab of the University of Kalamata. And these data are still provisional. Next summer, there will be more geophysics and hopefully further remote sensing exploration in order to expand the coverage to a wider area. But speaking of expanding to a wider area, we can move to the last GIS case, this time of regional scale, that of Laconia. For this region, archaeological evidence is considerable in both amount and significance, but the relevant data tend to be, for the most part, scattered, and they lack a bit in consistency. There are several data sets that require attention, and I have been working on some of them, out of which I'm going to present two. The first is the Laconia survey. The project needs, of course, very little introduction, especially in this very location, but the amount of information it produced is immense, and its quality is rather superb, and therefore we very much need its data onto a digital form. At the French school last December, I had the opportunity to present some preliminary work and the methodology I've used in digitizing the Laconia survey data. And now happy to say that its full digitization is completed for both the survey area itself on the eastern area of the Eurotas, the black dots, and the regional site catalog in the orange dots. So besides some polishing work that is still required, the core of the data, which mainly consists in 779 sites, I mean dots in this case, georeferenced according to the coordinate system internal to the project. And here we can see the reconstructed grid in red is now deployed on a digital map. I'm quite happy with the location of almost every site, and this example, the Amyklaion, shows that the site points spotted on the basis of the coordinates correspond quite nicely with the map. And the same is for this other example in the area of Seleucia, where the site plan corresponds with the satellite photo and the plan grid with the general survey grid reconstructed, of course, in black. But we can see here already that regional catalog sites do not match every time exactly with the actual survey sites. If the black dot of the actual survey sites go into place without any particular issues, the offset of the orange dots gets more complicated in some area, such as in this one, where sites that should be on dry land end up bathing on the Maleatan Sea. This is surely because the waters are irresistible there, but perhaps also because I may have not done everything right, as this image may suggest. Here we can see the coastline that matches, the yellow coastline matches with the Google Maps one, but the grid doesn't match exactly with the yellow grid doesn't match really perfectly with the red one, like here, for instance. And any idea or suggestion from the audience is very welcome, either in the discussion later or private. But last, I would like to present one more data set I managed to digitize, which is that by Yannis Pikulas on the road network of Laconia. Also, this work, of course, needs no introduction. It offers an impressive amount of data, well organized in a useful catalog, where individual entries are enriched by a set of coordinates. And instead of typing this information by hand, I scanned the relevant pages of the book and then obtained a digital version of them, from which I could use extract the coordinates and use them to feed the GIS and identify the spots on the map. But this method allowed me also to include all the information of the sites on the GIS. And in addition to the catalog, the author also proposes a map with his reconstruction of the road network. And in this occasion, my patience was road tested, so to speak, because I used 983 trigonometric points of the Military Geographical Service as control points to georeference this map. But I was then quite happy about the results. And this is how the whole work looks like, though I still have to vectorialize the courses of the roads. But this is just a matter of some elbow grease and some more patience. But I don't want to ask too much out of your patience. So I conclude here, and I thank you all for your kind attention. Thank you.